Welcome to lesson 4.1. This lesson comes from our Math in Focus 6th grade textbook, or course 1 of Math in Focus. We are comparing two quantities, so we're going to use some ratios today. We're also going to have to consider finding like units, or using conversions to create two units that are alike. We do have a notes packet which we have been using in class. However, for lesson 4.1, I know that the conversions aren't introduced terribly well in lesson 4.1, and then you get home and you're expected to be able to use this idea of conversions in your homework. For that reason, I've developed this page. On this page, I tell you to reference page R8 of your planner. So in your student planner, there are reference pages at the back. And from those reference pages, you'll find these conversion charts to help us make like units today. I have written out 3 examples for us on the board. I'm going to move the last 2 kind of out of the way for a minute. And if you look at example 1, I have a ratio written. I can tell that it's a ratio and that it says 6 feet to 1 yard because of this colon that's happening here. So I know that there's a comparison happening. Well, with these ratios, we'd like to write them in simplest form. But I can't do that yet because these units don't match. Here I have feet and here I have yards, and these 2 things are not alike. I want you to use again your reference pages, or maybe you're going to look at the copy of information that I found here on the side. We're looking for something that's going to help me go from feet to yards or yards to feet. Well, I noticed that in linear units here in this first section, it says that 3 feet is the same as 1 yard. Well, I have some options then. I could turn my feet into yards, or I could turn my yards into feet. I know as a 6th grader it's really hard to decide which one to use. And I think when you're unsure, it's always better to start with a larger unit. So when I think of feet, I know they're smaller than yards. So let's go ahead and change our yards into feet somehow. Let's take that larger unit and karate chop it, hiya, into tiny little pieces, or smaller pieces called feet. Well, looking back at our table here, how many feet are in 1 yard? 3. So if there are 3 feet in each yard, it's like taking my yard times that 3. Well, 1 yard times 3 is definitely 3. There should be 3 feet in one of those yards. Well, then I have students that oftentimes would like to change the feet to yards, and we don't need to do that because I really want to keep my units alike. These are called like units at this point. Now, this is not a final answer. If you were to be working with this ratio, we do need to get those common units first. But next we ask if we can simplify, and the answer here is yes. You should notice that there is something that divides nicely into both 6 and 3. We would call that the greatest common factor. So here I notice that they both divide by 3. I'm going to try that with both terms. 3 divided into 6 gets me 2, and 3 divided into 3 gets me 1. Notice I now have 2 feet compared to 1 foot, and this comparison still has these like units. But because these units are alike, we really simplify the writing process, and we could just write 2 to 1, meaning there are twice as many feet on the left or the first term than there are in the second term or on the right. We're going to try this again, but we have some other units coming at us this next time. So if you take a look for example 2, oops, that didn't work so well. If you take a look with example 2, apparently I need to be on my mouse. There we go. Example 2 is going from quarts to gallons. Quarts to gallons. There's a way that you could go from quarts to gallons or from gallons to quarts. And I always want us to consider what's the larger unit. So if you're thinking of a gallon of milk, it looks quite large. And if you're thinking of quarts, I'm trying to think of what comes in quarts. Maybe you would buy eggnog around Christmas time at a quart. Something smaller would be this quart idea. So I'm going to start with a larger gallon. And I'm going to look over here at my conversions. And I notice that I see this in the capacity section. So look for capacity even if you're on page R8 of your planner. Well, right down here I notice that it says gallons. 1 gallon goes with 4 quarts. So I, again, am going to take my 4 gallons and I'm going to make them smaller units. Well, if I've got 4 huge gallons, I'm going to get a lot more units that are a little bit smaller. So I'm going to multiply here. I like to start with the larger unit and break it down, because every time I do, you are going to create more smaller units. That means I'm always going to multiply. More and multiply. You're going to get more smaller units. What then is 4 times 4? Oh, 16. And we have just converted this into quarts. So I'll label it with a QT. And on the other side of my ratio, my first term gets to stay the same. Perfect. You might notice that our units match. And like I mentioned earlier, well, when that happens, you can take those units right away. We don't need that labeling any longer. But this would not be a final answer. You should notice something right here. This 12 and the 16, they're both multiples of a common number. So I'm trying to think of a common factor, maybe the biggest one that goes into both. Ooh, 2 goes into 12 and 16, how nice. But think bigger. Well, let's see here. 3 works for 12, but not for 16. How about 4? 4 goes into 12 and 16. Anything bigger? Let's try it. Let's divide by 4 on the left and the right. If it is in fact the greatest common factor, we will not have to simplify or divide again. If, for instance, I guessed wrong, or I chose something smaller than the greatest common factor, we'll just divide another time. How many 4s go into 12? Well, 4 times 3 gets me 12, so I'm going to put a 3 as my new reduced or simplified first term. How many 4s go into 16? Well, you'd say to yourself, 4 times 4 is 16, so 4 goes into 16 4 times. You do want to check, can this be simplified any farther? The answer is no. This would be my final answer of my ratio in simplest form. So again, remember, first we need like units. And I always start with a larger quantity and I multiply to get to a smaller set of units. That way there's never a question about whether you're multiplying or dividing, because I have students that kind of guess between those two operations. You'll always know. Let's go ahead then and clear this and try our third example. For our third example, you'll notice that this one's a little bit different. In fact, this one may not show up very easily in your planner on page R8. For this problem, I notice that I'm working in meters and centimeters. These definitely don't match. Meters are not the same as centimeters. Perhaps you've seen a meter stick, or perhaps you've been involved in a meter race. You know that meters are pretty long, like a long, long stretch, almost a leap when you're running would create a meter. But centimeters, well, those are quite tiny. Sometimes your teacher would tell you in elementary your centimeter is as wide as your pinky. Pretty small, right? These are not the same size. So please remember I said I always want you to choose the larger unit. So meters are larger than centimeters. That will help me remember that I'm going to multiply each time. I'm going to get a lot more smaller centimeters from this measurement. Well, I don't have that conversion over here to help me. So what I created for us today is a mnemonic that I like to use in my classroom quite a lot. If you notice, I have a K, H, D, M, D, C, M happening here. And these really stand for the units, the prefix of the metric system. So this would be kilo or kila. This would be heka or hecta. This would be deca. This is actually, this middle spot would represent metric units. We could have, for instance, liters, which is represented by a capital L. We could have meters, which is represented by a lowercase m. Or we could have a lowercase g, which represents grams. Next, we have the smaller units. Moving to the right, we have deci, centi, and milli. I like to remember this with my students. Kangaroos hop down muddy driveways carrying mail. That's right, kangaroos hop down muddy driveways carrying mail. Maybe you've learned King Henry doesn't usually drink chocolate milk. In that case, the U would represent the units, like right here, that U for units. Well, this is pretty helpful to you because if you take a look, we're moving from meters to centimeters. So starting here in my chart, it's like saying Maybe erase this for us for a quick minute. It's like saying I have 2 meters sitting right here, and the whole number 2 would have a decimal right behind it, wouldn't it? But I'm trying to convert this to centimeters, so I'm going to hop my decimal to the centi location. So 1 hop gets me to deci, 2 hops gets me to centi, right about here. And if you notice I have these openings, I might want to put some placeholders in here so that I can turn it into a more valuable or meaningful number. It looks to me like there are 200 centimeters in a meter, and you'd be right. Maybe you know that centi, kind of like century, stands for 100. So there must be 100 centimeters in each of those meters. Well, to do this conversion, I can also show this. If there's 100 centimeters in 1 meter, I'm going to take that 100 centimeters times 2 meters. So what happens here? We get 200 centimeters on the left, or as your first term of the ratio. And on the other side, should we change this? No, we better leave it alone. We already had centimeters, and now we match. We have like units. Fabulous! So you might say to yourself, let's get rid of the unit labels and just write 200 to 50. And you might say, that's even better. But I think we can take it one step farther. If you remember, we don't want to give a final answer unless it's in simplest form. So for this problem, I notice that these both end in zeros. Big clue to me. I know that they will simplify. They must share a common factor. Maybe of 10? Yeah, 10 would work. Things that end in zeros definitely divide by 10. But can I think bigger than that? Oh, 25s. I can think 25.50, or lots of quarters would get me to 200 cents or $2. That would work also. But I almost wonder if I could use groups of 50. Maybe 50 is the greatest common factor. Let's try it. So I know 50 goes into 50 one time. I can take care of the second term pretty quickly. But on the other side, with this first term, how many sets of 50 go into 200? Well, let's see. 50, 100, 150, 200. How many sets was that? Using tallies, we found that 4 sets of 50 go into 200. Can this be simplified any further? The answer is no. This would be a final answer. Now that you have 3 examples of conversions for your notes, I'd like you to take a look at the worksheet that was recently assigned and is actually due when I see my red hour, my accelerated 7th grade students on Wednesday. So let's see if I can find that for us now. So here is our assignment. It looks like we are comparing 2 quantities using ratios. I'm not too concerned about my students when they get started here. Jacob and Olivia, they both have some grapes and some oranges, and we're doing a comparison, and we're going to tune into the order that matters. So in a minute, I'm pretty sure my students are equipped to remember that if they ask for grapes first and then oranges, I will give the value of grapes before I give the value of oranges. I'll also need to make sure that I'm simplifying if possible. I do want to fast forward to the second section because, again, I'm not sure that our notes adequately prepared us for this. So if I kind of highlight this, oops, it's not really letting me do that. So I guess we will just look at this second section, which is sitting here. It says, state whether each of the following can be expressed as a ratio. If yes, express the ratio in simplest form. Something that I have seen a lot of teachers say is, well, just write yes or no, right? Either yes or no. It says state whether it can be expressed as a ratio. That's a yes or no. Yes, you are right. There is a yes or no happening here. I don't love that because that sounds like a 50-50 guess to a lot of students. That sounds like a 50-50 guess to me. And I'd rather have a meaningful answer here. So I want you to consider with me real quickly, what do yards measure and what do inches measure? Well, yards, if you take a look at page R8 of your planner, you will find that that's under linear length. It's under length, or unit, which is customary for measuring straight linear measures. So this has to do with length. I want you to look in your planner on page R8 again and see if you can find me inches. Well, you should notice that it's actually in the same section. It's going to say that inches. Oh, they also measure a linear length. They have to do with straight lengths of measure, length. Do these two types of units match? Meaning, do they measure similar things? Absolutely. Length is the same as length. Yards, of course, are longer than inches, but they both measure a type of length. So the answer here is definitely yes. There was not a question in my mind. I didn't guess eeny, meeny, miny, mo, yes or no. I actually thought it through. They both show length. Now here's the challenge. It says if yes, you get to express this in simplest form. So let's go ahead and write 2 yards to 60 inches. If you think back to the notes that we were just taking together, when I don't have like units, I start with the larger unit. Yards or inches, which one's larger? Oh, that's right, yards are larger. So I'm always going to start here, and I'm going to multiply my yards by however many inches I would find in a yard. So I hope on page R8 it shows you that maybe there are 3 feet in 1 yard, and each of those feet requires 12 inches. So let's see here. 3 feet equals 1 yard, and 1 yard equals 12 inches. Something along that line is going to be very helpful to me. So if I have 3 yards, not just one of them, it's like saying I'm going to have to multiply this by 3. How many inches then are in a yard? 12 times 3 is 36. 36 times 2 would get you, 30 times 2 is 60, 6 times 2 is 12 more, 60 plus 12, 72 inches compared to 60 inches. Remember, I'm keeping the smaller units the way they were given. Yay, I have the same size units. Let's go ahead and do a rewrite step. And I'm noticing that Math and Focus does not give us much space for formatting and writing out our thinking. So don't be afraid to grab some lined paper. I probably should have done the same. Now this can't be a final answer because they asked for simplest form. We need to see if there's a common factor that divides into both. And I see, in fact, there is. So think big. Well, they're both even. 2's not very big. Can we get bigger than that? I think 4 goes into 60. 4 times 15, I think, would get me there. And I think 4 goes into 72 also. Yes, it does. But I'm going to think bigger than that. Yeah, you know what? If you keep looking at your multiplication chart, you look for 72 and 60 in the same row, you might see that the GCF, greatest common factor, might be 12. Let's give it a try. How many 12s in 72? Well, the answer is 6. How many 12s in 60? Well, the answer here is 5. 5 times 12, check that. Yep. 50 plus 10, that's 60. 6 times 12, yep, that's 72. Is this in simplest form? Indeed it is. It's a final answer. Now I really don't want you to go ahead and say, oh, I worked so hard on number 2, I'm just going to guess on number 3. Yes or no? Watch me go. That is so dangerous, and it's lacking a lot of meaning. So I don't just want to guess or no. I really want your thinking. So let's talk for a quick minute. Even though I'm a little out of space, I'm going to erase here for us. Okay, don't erase your paper. Get some extra paper if you need to. Let's talk about these gallons and these tons. They definitely do not look like they're the same size units because they don't have the same name or anything. But I noticed that gallons are found underneath capacity. Capacity might be underneath liquid capacity on page R8, or it might say a fluid capacity, something along that line. Now tons, that's not underneath liquid capacity. Oh, you know what? Tons might be listed underneath weights as a measure, or maybe mass. It kind of depends on what your reference page lists it as, but I have to tell you that this fluid measurement of capacity is not the same as the weight or mass of an elephant, of tons. So will these ever be the same? Should I liquefy my elephant, turn my tons into liquid? Or should I take my gallons and magically turn that into a weight or a mass of an object? The answer would be no. That's not really possible. So in this case, there's no other ratio writing to do. We cannot write this as a ratio or comparison because there are not similar measurements. All right. Let's fast forward here if we can. Easy for me to say. I can't get to number 4, but I'll try. And let's talk about this next section. Oh, complete to express each ratio in simplest form. We just want to complete these. But here's the trouble. I noticed something instantly. Feet are tiny, yards are big. These don't match. So take a look at what they did. Here they're changing them both to feet. Hey, that's just like I suggested to you, that you always take the larger unit and turn it into the smaller kind of unit, or the smaller measure. So does anyone remember how many feet in a yard? Take a look at your conversion charts on page R8, and you will see that there are actually 3 feet in each yard. Well, if that's true, the first yard has 3 feet, the second yard has 3 feet, the third yard has 3 feet, and so on and so forth. I better multiply. If I always start with the larger unit, I'll always be safe to multiply. So, did this first term change at all? The answer is no. I still have 18 feet sitting here. Did the second term change at all? Absolutely. I went from yards to feet, and I got more of them because feet are smaller. And I know 3 times 5 is 15. Perfect! Then they leave me these lines, and I could go ahead and take off the units because they finally match. But you'd be wrong. It's not a final answer. You can't be a millionaire yet. So what would I need to do as a last move? Consider simplifying. What divides into both 18 and 15? Well, you're looking, they're not both even, that won't work. Does 3 work? Absolutely. They both divide by 3. And if you remember back to elementary school, one of the rules here would be if you add the digits together, 1 plus 8, and then it divides by 3 nicely, that whole value of 18 will also divide by 3. Well, let's see, 1 plus 8 is 9. Oh yeah, 9 divides by 3, so 18 will also divide by 3. How about this one? 1 plus 5? Well, that's 6. 6 definitely divides by 3, so 15 will also divide by 3. So, final answer. Let's give ourselves a little more space here. They didn't give me enough to work with. 3 goes into 18 6 times, and 3 goes into 15 5 times. I have a final answer and simplest one. If you take a look at this next problem, number 5, it's talking about ounces and pints. I do believe on page R8 you'll have luck with that. And I also know if you quickly Google and you find out how many ounces in a pint, it will give you a really quick answer. I also might refresh your memory if you remember gallon man. A giant G represents the gallon, and inside this gallon we have 4 quarts. Well, those are still the larger units than what we want to work with right now. But if I break these quarts down, inside of each quart are 2 pints. Ooh, we're getting warm. If you can remember how to build this before a test, it's kind of beautiful because it sticks in your head. And inside each of those pints, I know you'd find 2 cups. Cup, 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 and so on and so forth. So where are the ounces hiding? The answer is underneath the microscope. Inside those cups, you'll find 8 ounces. 8 little ounces in each one. So let's think about that. If there's 8 little ounces inside this little cup, and 8 little ounces inside this little cup, how many ounces does that make in 1 pint? The answer is 16. So I know I have to use the 16 ounces somehow. Will we multiply or divide? Well, if you follow my rule, you're always starting with a larger unit and breaking it into smaller pieces. You're going to get a lot more tiny parts. We're going to multiply. We're going to multiply our pints, 3 of them times 16 ounces. Did the first term change? Nope, stay the same. Keep it the same. But the second term, 16 times 3, well, that'll get us a different value here. 3 times 10 is 30, 3 times 6 is 18 more. That gets me 30 plus 18, 48 ounces. Great, the units match. Let's take off those labels and say, hold up. There's one more move, isn't there? Here we're missing simplest form. So what could I do to both my 30 and my 48 to get down to some lowest terms? Just like we would with a fraction, we're looking for the greatest common factor. Well, what divides into both? They're both even, how nice. I could try 2 first, but I might have to keep on going. Oh, I noticed 5 works for 30, not for 48. Let's see, something else going both. Oh, I noticed that 30 and 48 are both in the same row on my multiplication chart. It says that they both will divide by 6. We could try it. This could be the greatest common factor. 6 times something is 30. 5. 6 times 5 is 30. 6 times something is 48. Check my chart. 6 times 8 is 48. Can I simplify any more? The answer would be no. 5 is actually a prime number, if you remember it. Only divides by 5 or 1. And because 8 doesn't divide by 5, we must be set. Nice. This next section, I believe you're well equipped for. You're going to have to be careful. Number 6, super nice. You're just going to simplify. But number 7, 8, and 9, you're going to have to find me what? Like terms. The last thing I'm going to look at with you is on the back side of this worksheet. And I do want to remind you that you don't have to watch every single piece of my videos here, right? Please fast forward to the things that you need or you find the most valuable. I'm going to fast forward to number 11, and the reason for that is because there are so many pieces to it, and I just feel like my students really struggle in how to make this work. So for number 11, it says Taylor's making punch. She mixes 1 gallon of orange juice, 3 quarts of cranberry juice, 5 pints of apple juice, and 8 ounces of lemon juice in a large pitcher. Find the ratio of the following amounts. Hold up! I heard gallons, then I heard quarts, then I heard pints, then I heard ounces. Oh my gosh, make up your mind. Taylor, this is going to be really hard to do unless we get these to similar units. So let's talk for a quick minute. Could we take each of these ingredients and turn them into the smallest type of unit that's listed? Here I have my OJ for orange juice. I have my CJ for cranberry juice. I have my AJ for apple juice. And I also have my LJ for lemon juice. So I'm doing some really quick coding just to keep track of things. How much orange juice did we have? Oh, 1 gallon. How much cranberry juice did we have? 3 quarts. How much apple juice did we have? 5 pints. And how much lemon juice? 8 ounces. Looking at your conversion charts, can you figure out which one is the smallest type of unit? Or if you think back to gallon, man, and how we drew this out, can you remember what was the tiniest little thing listed inside there? Oh, they're so tiny, those little tiny ounces, they're in there. That's what I want to turn all of these into. So you know what, I see something. We can leave this lemon juice alone. But I want to get from 1 gallon to ounces. That's going to be a little bit tricky, so we're going to have to think for a quick minute. If there are 8 little ounces in each little cup, that would make 16 in a pint. And there are 2 pints in this quart, so 16 times 2 is 32. So there's 32 little ounces in this quart. But what about these other quarts? There's 4 of them total. Oh, it's like saying 32 times 4. So somewhere you're showing me this work, 32 times 4, or 4 times 30 is 120, and 4 times 2 is 8. Oh, looks like I'm going to get 128 ounces. You may want to double check this. I'm doing some really quick mental math for my video today. I think we got it. I think if there are truly 16 ounces and 1 pint, 16 more in the second pint, 16 and 16 makes 32. And I know that I have 4 quarts altogether. I need to multiply that 32 times 4. All right, let's talk about these 3 quarts of cranberry juice. Oh, we have to turn these into ounces somehow, but how are we going to get there? This is where I really want to see your work. So I don't want you just to write down what I've done. Just watch my video and write down the answers. There's no learning in that. I want you to take a quick minute and think it through. So how many ounces did we say are in 1 quart? 32. And I need 3 of those quarts. So this time I'm going to take 32 times 3. Some quick mental math. 3 times 30 is 90. 3 times 2 is 6 more. 90 plus 2, so I'm going to get 96 ounces here. And then there were pints, and I wish that they were ounces. So let's see if we can change our pints into ounces quickly. Oh, let's back up here. Inside 1 pint, I showed you that there was 32 inside 2 pints. How much was there inside 1 little tiny pint? Oh, there's 16 little ounces in 1 pint. So I want how many pints? 5 pints. So 16 ounces times 5 pints. Well, 5 times 10 is 50, 5 times 6 is 30 more. 50 and 30 gets me 80 ounces. Looks like I'm heading in the right direction. And again, this lemon juice, not much of it being used, 8 ounces can stay in ounce form. Let's go ahead and get you started with part A. It says I have orange juice to apple juice. So I'm going to use my shorthand here. OJ to AJ. Let's go over here and find from the chart what we need. OJ. 128 ounces. I'm not going to list the units right now because I have turned everything into ounces. I'm good to go. But I do need to find apple juice in ounces. Oh, right here. 80 ounces of apple juice. Now this cannot be a final answer because we're supposed to simplify. So I need you to think of the greatest common factor that will work here. So you might say that they're even, you might divide them next by 4. I want you to think this through. This is not a final answer, but it gets us pretty close. So again, consider dividing by the greatest common factor. Might take a couple steps. For the next one, do the same idea. You need to show me CJ to AJ. So I would write CJ to AJ. And next I would list what I have from cranberry juice and from apple juice. And then I'd think about simplifying. I hope that this gives you a good start for number 11. I know that number 10, 12, and 13 tend to be kind of challenging problems for my students. I would encourage you to consider a bar model for those. But I think for today's purposes, I'm going to stop my video there, and I might go into a part 2 for next time.